In this video, I will be introducing you to the concept of voltage, what voltage is, what it does, and the different forms voltage takes. What is voltage? Voltage is a measure of the difference of electrical potential energy between 2 points. This potential difference will stimulate a current flow. As a result of this electron flow or current, voltage can also be called EMF, or electromotive force. Let's look at what a volt is. A volt is the standard unit for voltage. It is represented by a capital V. 1 volt is defined as the amount of energy in joules required to move 1 coulomb of charge. 1 coulomb is equal to 6.24 times 10 to the 18 electrons. Now let's look at what voltage does. Voltage is an energy source in many circuits. A common example of a voltage source is a DC or direct current battery. Here we see an example of a common 9-volt battery. Let's look at the different types of voltages. There are 2 types of power that we use today, DC and AC. AC power is what you get out of a wall plug that you use in your home. In this form of power, the voltage is constantly changing and it can be graphed as a sinusoidal waveform. The other form of power is DC. This has a constant voltage and is the type of energy you get from a battery. When graphed, it is seen as a straight line. Voltage division. Voltage is energy. As such, it must be divided across the components in the circuit. This is the basis of Kirchhoff's voltage law. This law states that the sum of all the voltages in the circuit equals 0. In other words, the voltage dropped across all the components is equal to the value of the voltage source. In a series circuit like we see here, the voltage drops are based on the value of the resistance of the component. In this diagram, the voltage dropped across each resistor will be 3.33 volts, as they are all equal in resistance. In a parallel circuit, voltage across each branch divides equally, and the current changes, unlike in series circuits where the current is constant, so no matter the value of the resistors, the voltage across each branch is equal in this diagram. AC voltage and current have some interesting interactions with 3 common circuit components. These components are the resistor, capacitor, and inductor. These effects can be seen when the AC voltage and current waveforms are graphed. In a resistor, the current and voltage remain in phase with each other. This means that the peaks and troughs of the waveforms remain aligned. In both capacitors and inductors, the AC waveforms are out of phase. For a capacitor, the current will lead the voltage by 90 degrees. This means that the current waveform rises 90 degrees along the graph before the voltage waveform rises. For the inductor, the relationship is inverse. In this case, the voltage leads the current by 90 degrees. Thank you for watching this video on voltage. I hope it was informative and enjoyable to watch.